Hey everybody, how's it going? Welcome back. So today we're going to look at the idea of turning our generating data thing into an actual function so that we can call this and get new data. So what we talked about last time was generating some sort of x and y pairs where the y is roughly linear with the x's, as in, it's mostly that you can draw a line through these things. Except we also add a random component because in real life, there's going to be these drops like this or these increases where the data doesn't perfectly fall into a line. We want to get some randomness. So let's turn this into a function. Well, I'm going to call or make a function. We'll say generate data. Okay. And now what do we want to take for this thing? So there's a bunch of different ways you could do this, except definitely I want to supply it these beta naught and beta 1 here, which is the underlying intercept. So if you were to think about drawing a line through this thing, you would get a intercept of whatever it is down here, which is roughly 2. Okay, so that's 2. And then the slope is 3, meaning you can see as x goes from 1 to 2, a 1 unit increase in x, the y is going to go up by 3. X goes from 1 to 2, y goes from 6 to 9. It goes up by 3 when x goes up by 1. So that's the slope there. And so definitely we need those two things. And so I'm going to denote this again as params just by saying the dictionary. We're going to pass it in as this dictionary here instead of doing beta naught and beta 1 separately. Okay, so now that we have that, what else do we need here? So turning this into a function. Well, how did I get these x's here? I just kind of picked them randomly, and I did happen to order them, although you don't really need to order them. Really what I would do for the data is to find some valid range, because in regression, your line, it fits some data between some lower x value and some upper x value. For here, our range is between 1 and 4. So I just picked some range. So really what I want to do is x lower and x upper. Okay, and again, I just chose arbitrarily that these are going to be two separate parameters. They're each going to be a number. So we supply x lower as whatever my lower range is, x upper, whatever my upper range is, so that we can generate random x values between this range. And to make a proper line between these two, we're going to need to generate a fair amount of data, maybe 10, 20, 30, 40 points, whatever it is. But after we do that, then we have the x values. Now the final thing is the y values from this, and here I also chose this kind of arbitrarily between -1 and 1. So I'm actually just going to keep that as is. I think it's okay, so I'm not going to make that a parameter, but you absolutely could make that, you could make rand lower, rand upper as parameters. Okay, so what are we going to do with this thing? Well, we're going to want to return x and y. Okay, so we want to return the list of x and the list of y. There's several different ways to return two different lists, but I'm just going to do it as what's called a tuple. So in the end, I'm going to return something that looks like this, where we have x list, and y list, so that I can get both of those later. And the corresponding, so the first element of x list is the corresponding x with the y value. So I want to return this thing at the end. So clearly I'm going to start with x list is equal to something and y list is equal to something. Okay, just empty lists so that we can build these things up. Now we're going to build the x's first because the y's are dependent on the x's. So to build the x's, really that's just random values between x lower and x upper. So something else that we need, which I forgot about, is going to be n. And that specifies it's going to be a positive value, which says how many different pairs we're going to have. So both x list and y list are going to have length n. Okay, so we need to say basically for I in range of n, so that just means this is going to go over the list n times. And so each value will say xi. Xi is going to be, well, we already looked at this thing. We saw random.uniform generates random between -1 and 1. So there's no reason we can't just do random.uniform of x lower and x upper. Okay, so that's going to be some value in whatever range we specified. If we gave it 1 and 4, it would be some value between here. If we call that enough times, we should get a fair amount of spread between 1 and 4. Sorry for the notification sound there. So xi is random.uniform x lower x upper, and after we have xi, well, I can just append that to the list. I can say xlist.append xi, and so now x's should be a list of n values between this range. And so let me just test this right now, is if I was to call this, and I'll get rid of this because we don't really need that anymore. Okay, if I was to test this thing with generate data, and we had params, which actually I can just say, I can keep this over here as these dummy parameters. We're not even using them. This is just testing. It's just testing the x stuff. So if we give this parameters, and we need x lower and x upper, so I'll say between -2 and 3, and then maybe give it, say, 20 values. Okay, so generate data. It's going to be, so this is the y thing, which is empty, but here we have all of the x values, which sure look like they're a bunch of values between -2 and 3. But now that we have the x's in here, and you can actually do this in the same loop, is we can get yi is equal to what? Well, it's that slope, or that intercept, which is, we can get the parameters right here. We can get beta naught is equal to params sub beta naught, that's how we're storing it, so we're just extracting that out. Beta 1 is params sub beta 1, and now we have those parameters. So yi is definitely beta naught, whatever we gave that, plus the slope, beta 1, whatever we supplied there, times that x value, so times xi. And then we need to add in some randomness, okay? We don't want a perfect linear relationship. In fact, if I keep this as is right now, and I do ylist.append with yi, and we call this with generate data, okay, what the numbers are here doesn't really matter. If we get, so we can say data is equal to this thing, which is going to be the first element is the list of the x's, the second is the list of the y's. So we can say xlist over here is equal to data sub 0, and ylist is equal to data sub 1. And then if we do that same thing, plt.plot, which I may not have imported already. Yes, it's in there. So plt.plot with xlist and ylist. Sorry, I just wrote one too many brackets. If we do that, we get a perfect line. And again, this is plot, which does align. But if I do scatter, then you can see it perfectly follows a line. We don't want that. So we're going to do plus random.uniform, some decided upon amount of randomness. And we'll just say a value between -1 and 1 with equal probability. If I do that, now we can see, okay, there's some sort of spread here. It's not just a perfect line. There's some error, there's some noise, and we can have a model that doesn't have 0 MSE. It's going to have a non-zero amount of error, which is the normal. That's what every single data set that makes sense is going to have, okay? Hopefully that was fun. I will see you in the next video.